can make them up. I assume by exponent problems you mean like that?
Yeah, pretty much.
Only harder, I presume.
Yeah.
Let me get my book and see if I can come up with anything. Hold on a second. Let's see. Exponents. Hmm. 464. Actually, my chapter on exponents is referring to exponential functions rather than exponents. So, I'm not sure I have a set of problems. Let me look again. Hold on. Where would these be?
Let me look in my book and see if there's any others, but I'm not sure there is.
Okay. Here we go. I just found it. Using properties of exponents. In other words, I don't think you want to deal with questions like this, right? That's an exponential expression there. That's not an algebraic expression. So, okay. Do you know the 5 rules, basically, that apply to all exponent problems? I use B as the common. You know what this is?
BXY.
What's this one? The second one?
B.
Okay. I'm going to show you how I memorize these. Notice that whatever we're doing here, if we're multiplying, we add. It's not bxy, it's bx plus y. When you're dealing with exponents, when we're dividing the bases, we subtract. Subtraction is one level less mathematically than division. Addition is one level less mathematically than multiplication, and multiplication is one level less than exponentiation. So that's how you memorize these rules with exponents. If you're multiplying, you're going to add. If you're dividing, you're going to subtract. If you're exponentiation, you're going to multiply. Okay? So those are the three. Those are the 3 main rules. There's also a couple of more that you want to be aware of that apply when you have different base. For instance, if I have b to the x times c to the x, different bases, same exponent, then that's the same as bc to the x. And if I have b to the x divided by c to the x, that's the same thing as b over c all to the x. So these 5 rules are going to cover all exponent problems.
Okay.
So let's find some. Let me go to the back of this chapter, and I'll just go through the exercises. Now, I can't really tell whether this is honors difficulty or not. You know what I'm saying?
Yeah.
When I bring the problems, I bring the problems that are out of my book, but they may not be the same level of difficulty problems that you're doing in class. So it's always better if you bring the problems. Because you know.
Yeah, I have a lot of them in my book, but I've just done all of them.
Okay. Well, let me know if we're getting close with some of these. What's the answer here?
4 to the 8th.
No, we're multiplying, so what are we going to do with the exponents? One level less, mathematically. One level less than multiplication is addition. Is that equal to?
Is that a 5 or an S?
I'm sorry, that's a 5. Wouldn't really matter, though. Let's make it an S.
5. 5 to the negative 6th.
There you go. Because we're exponentiating, we want to do multiplication. I'll just go through these.
That is
same base, different exponents.
so it'll just be negative 9 to the 3rd.
Add the exponents. That exponent is 1.
Yeah.
It's to the 4th. Okay, what's 8? And then whatever that number is, it's going to be 81 squared. And it will be positive because it's an even exponent, and that exponent acts on the negative 9 also.
Eight to the 6th.
That's 5 to the squared divided by 5 to the 5th.
Here, I have 2 we can do that are a bit harder.
Okay.
X, A minus B, and that's all in parentheses.
X to the power of A minus B?
Yeah.
We've done this one.
And then X, A plus B. Yeah.
Oh, it's not that one? Okay. Okay.
And then to the 3rd power.
Like that?
And this, it has the parentheses over the X as well.
Ah. So it's this that's to the 3rd power.
Yeah.
Notice that that matters quite a bit. Because if it was the exponent to the 3rd power, I'd have to cube that. Now I don't have to cube that. So let's get rid of one set of parentheses at a time. Always start from the inside and work out. So what does this turn into?
X3A plus 3B.
Now, what's that equal to?
X to the 4A and X to the 2B.
So it's plus 2B.
Yeah.
It's X to the 4A plus 2B, like that. Okay, and we have done this one before, only I think we started at this step right here the last time, but what else you got?
The next one
I
is...
could have done that with somebody else. I've been doing a lot of algebra too lately. In fact, I found a student that gave me the same set of problems our last session on Sunday. You know that stuff you emailed me? I had a student 2 hours later, and she had the same exact set of problems, which I thought was funny because I had never seen those kind of problems before. And I figured out why we were looking at those kind of problems, because those problems defeat the inspire. In other words, if you can factor on an inspire and I give you a polynomial, you just put it into your calculator. But the problems that you had sent me where we have to fill in a blank, you can't answer those on the calculator. You have to understand the concept of factoring to be able to do them, which I found cool. I'm glad that they've come up with ways that still make you think and know how to factor, you know, even though your calculator will do it.
So on the calculator, can you factor problems that are like 9k cubed minus 25k?
Yeah. Yeah, you can. I just did it. Now, mine is a whole lot easier to do than yours.
Yeah.
I don't have to go through that process of choosing polynomial and then saying whether it's real or quadratic, and then they give you the solutions as the solutions and not the factors. So, is this one of your problems right here? Or is this just a
that's one of them.
That's a factoring problem. Well, the first thing I'm going to do is take out a k, and then what am I left with?
9k squared minus 25.
And then what is that?
3k minus 5, 3k plus 5.
Right. That's difference of squares. So, yeah, my calculator will do that and give me the answers as the linear factors.
So mine will do that as well. It'll just give it to me in the actual answer.
Once you upgrade your software, yes. But at the moment, the only way yours has to factor, I believe, is that method I showed you. And the only reason I knew of that method is because I had immediately gone online, looked up how to do it, and the only video I saw on YouTube was the one using, he had a calculator that wasn't the most current software version, so he had to do it your way. And I looked at my calculator and I saw, wow, there's a factor option there. And if you put the factor option is all you do is type in the polynomial, hit enter, and you've got the linear factors.
So yours can factor pretty much everything.
I haven't tried really hard ones, but I did try a cubic about an hour ago with a student, and it worked just fine. Gave me 3 factors.
Nice. Okay, the second exponent problem is negative 3a squared. That's all in parentheses.
Like that?
Now the squared's inside the parentheses.
So the square is only acting on the a, not the negative 3, okay?
No, it's only on the a.
Okay.
And then right outside of that is a third power.
Okay.
And then after that, negative a to the fourth is in parentheses. And then a square outside of that.
Okay. like I said, the only thing you need to do all of your exponent problems are primarily these first three rules. It's rare. So far we haven't had a problem where we had to use this rule or this rule. So these three rules are enormous. They not only apply to exponents, they're the same three rules that apply to logarithms. If you remember, you haven't had logs this year, but you probably had them last year, didn't you? No, probably not. Have you had logs yet?
I don't think so.
Same thing applies with logs. The log of x times y is equal to the log of x plus the log of y. So that's because logarithms are exponents. That's what they are, is exponents. So let's get back to this one. So let's do the exponentiation first in both problems.
Negative 3a to the 6th and negative a to the 8th.
Okay. This 3 is operating not only on the a squared, but also on this negative 3, because it's all in parentheses.
Oh, okay.
So it's negative 3 to the 3rd, a to the 6th, and since the square is operating on this negative also, it turns it positive, so now we have a to the 8th. Now what? What's that equal to?
Negative 27a to the 14th.
Yeah. So the degree of complexity doesn't really matter. It's all about those first three rules. No matter how complex they want to make it, as long as you start from the inside and work your way out, in other words, do your exponentiation first, and make sure you're exponentiating everything that's inside the parentheses.
So if there's a parentheses over all of it and there's an exponent on the outside, that exponent acts on everything in the parentheses?
Yeah, exactly. And the same reason that this 2 operates only on the a. It does not operate on the minus 3. But of course, if I wrote this, now the 2 does operate on the minus 3.
Okay.
Okay? I can find some, I think, that are that degree of difficulty. I was just starting at the front, but I got some here. How about this one here?
These problems are so much easier now that I'm finally starting to understand the rules.
Yeah, that's all you got to do. Exponents are really easy because there's only 3 rules, really, that you have to apply. And if you remember that concept about being mathematically one level less, it's pretty easy to memorize those rules. Okay. Avoid negatives if possible. In other words, if I try to do this problem and I start with this part of it, I'm going to end up with what? X to the what? What is x divided by x to the 4th equal to?
X to the 3rd.
Okay, what's the exponent here?
1.
And what are we going to do with the exponents?
Divide. Or minus would be negative 3.
Okay. So that's the answer. Okay? So if I were to do this, I would have a negative exponent. And there's nothing wrong with negative exponents. It's just that negatives lead to mistakes more than positives do. So instead of doing this first, let's multiply the numerators first. First of all, I can take that out immediately, right?
Mm-hmm. Yeah.
And I can take the 4 out and make that a 3. So now, let's
So that's the first step?
I think so. Yeah, you work with the numbers, and then you work with the x's, and then you work with the y's. But the question is do you do the division first or the multiplication? And in this case, the multiplication makes sense to do first because it's going to leave us with nothing but positive numbers. So
Okay.
3 goes in the numerator. We're just doing the numerator now. How many x's? What's the exponent on the x?
6.
And the y?
3.
Now I'm going to divide that. There's no number. I got an x to the 4th and I got a y. So now it's
That would be
it's easier to deal with that because it leaves us nothing but positive numbers.
3x to the 2nd and y to the 2nd.
Exactly. We'd have gotten the same thing doing all of that first, but it could have led to mistakes more easily. Notice we had no negative numbers at all in this one. And if you don't know that, let's do it the other way, just so you can see that it really doesn't matter. You're still going to get the same answer. Let's do this one first. So we would have 12 over 7. The x would go in the denominator like that, and we would have a y there. Okay, so I've simplified this first expression to this.
Okay.
Second expression, I'm going to simplify to 7 there, x to the 5th up there, y, just straight y, because it's y squared, or y squared divided by y is y to the 2 minus 1, or just y. And now I multiply my y's together, cancel out my 7's. Oh, I had this 4 also, so I still got to do that. And now I still get to y squared in the numerator, and x to the 5th over x to the 3rd is x squared in the denominator. But doing it this way, I had to make sure my x was left in the denominator with the proper exponent. There's always multiple ways to skin a cat, and I'm a firm believer in doing the way that results in positive numbers. For the same reason that if I give you this equation, I'm not going to move my 3x to the left and my 6 to the right. I'm going to move my 2x over to the right because that's going to leave a positive x. And that's what I want in my answer. I am going to move my 10 over, so I'll have a negative over here, but I can't avoid that. My answer is negative 4. But if I move my 3x to the left, now I got negative x equals 4. Now I got to translate that into x equals negative 4. So it's kind of following that pattern. Use small numbers if always, whenever possible, and use positive numbers whenever possible. Okay, should we do another one like that? Or here, I got one a little bit different.
Yeah, I'll do another one. That would be it'd be negative 8x to the negative 4th.
Okay, where are you getting the 8?
Oh wait, that's a square, sorry, 16. Negative 16.
Okay, what is this number right here? The negative exponent never means anything about negative numbers. Remember that. That's one of the biggest mistakes that algebra students make, is they think a negative exponent means a negative number. It doesn't. It merely means this. It means reciprocal. So it's 1 over 16.
Okay.
That's that applied to the 4. Now what about the x?
To the negative fourth.
Okay, and let's go ahead and write it, x to the negative fourth. You will sometimes be given instructions that do not give any negative exponents. And then what's the rest of it?
Negative 2y to the negative 10th. Or 2y, or no. More.
So all you're doing is this part right here. Multiplying the exponents. So it's the same base, y, to 5 times minus 2. Okay? Now, if the instructions were do not give any answers with negative exponents, how do I simplify this? What does that equal to if I want to use all positive exponents?
Negative 1/16 x to the fourth.
There's no negative. There's no negatives anywhere. This is 1 over 16. The x to the negative fourth merely means that it goes in the denominator to the positive fourth, and the y to the negative 10th merely means that that goes in the denominator to the positive 10th. So there's your answer.
Do you flip it? Oh, wait.
No, that's the answer. Now, notice I could have gotten to this answer by merely applying that reciprocal rule immediately. In other words, I could have rewritten this as 1 over quantity 4x squared y to the 5th all squared. It's very important that you understand that that's equal to that.
Okay.
Okay? In which case, once I've switched it to this, if this is my first step, the second step becomes pretty easy. Now we're squaring 4 to get 16. X squared squared is x to the 4th, and so on. In other words, doing this method gets rid of the negatives instantly and allows me to proceed with all positive numbers. So I actually prefer doing this step first.
Okay.
But it's critical you understand what this number is. Or we'll make it a square, make it easier on you. What's 5 to the minus 2?
1 over 25.
Yeah. All right. Hopefully that'll help you. Let's see, and we're going to meet again tomorrow night at 7:30, right?
Yeah.
Okay. I'll talk to you tomorrow night.
All right, bye.
All right, Jackson. Bye.